Hello, hello. Welcome to Hot Dogs, Horseshoes, and Hand Grenades. My last video, the main feature that I kind of showed off was the SR latch. As you can see here, this was basically a 4-module circuit that they built just to make sure you can store a bit or store information. I believe this current configuration is the low active. There you go. But in the latest update, all of this got compacted to just this. So now you have the S and the R, and here are the Q and Q prime outputs. I don't really know the notations that well. So I believe this is active high. So this could be used, to store information. So that is great about this update. From this to this. So what can you do with the SR latch? So this is a new circuit that I just learned. This is the 1-bit, I believe it's called the 1-bit circuit, 1-bit memory. So basically I used the SR latch to some things. I did not create this setup. I got this as I was Googling and learning online. So basically all of this can be used to store 1 bit of information. Boop, boop. Cycles between this and this. Pretend this is not here. That's like the 1 digit of a binary, so it's 0 and 1, 0 and 1, just for testing purposes. The reason why the article online utilizes 2 SR latches is because no matter how quick you push a button, no matter how fast the clock pulses, or push the button, it is a non-zero duration. It's going to last for a few milliseconds, where in that millisecond time it could basically flash and mess up the logic. But here you go. This is a 1-bit. Now, what's neat about this 1-bit circuitry is that it is stackable. So this is 1 bit, the second bit, and the third bit. So every time you can just chain these together, and you can basically have a binary counting system every time you send a pulse. So every time this sends true, it increments going forward. This could be any kind of input I think you want. You just get creative on this. So let's kind of reset this from the back. Let's show. Okay. And nope. Okay. So let's kind of read the top lights. So how do you interpret this? This is currently 0, 0, 0. And then when you send a pulse, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and then it rolls over to 0, 0, 0. So if you you basically get any number you want, but it's in binary. So you have for every digit you have, if you know about binary numbers, and it's basically 2 to the nth power, so 2 to the 1, 2 to the 2, 2 to the 3, you can have up to 0. Well, technically if you count from 0 to 7, basically count from 0 to 7, 1 to 7. I'm not doing another take. That was my alarm. I've been staying up a few hours figuring this out. That's how you know how tired I am. I am not gonna do a second take. Okay, but yeah, here you go. This is basically a counter system. Now, there's a few cool applications that, well, you can do with this. Let me take a pause right here. And we are back. So, let's say using the counter system, you can make like a gimmick target. Let's say that you want the user to triple tap the target. Quick aside, I'm using this as a pseudo target input because currently right now I think either I'm using this wrong, but the pop-up is not working properly where the output is showing true no matter what state it is in. So I'm going to be using this for now. So again, let's say you're making a challenge where make sure to triple tap every target you see. So using a counter like this, you can go, okay, it's right now that's 0 shots on target. Oh, messed up my wiring while trying to change things. Let me fix that. Okay, so let's say you have now 0 shots on target, and you go, okay, first shot, boom, 001. Okay, second target shot, 010 or 2, and then here you go, 3. Because we know that 3 has to be lit up as 011, we can make some AND gates and some NOT gates to say, hey, you did it. You hit the target 3 times. However, with this setup, well, if you put too many shots, well, then it kind of messes it up. So, what you can also do to keep that confirm, well, maybe a latch gate as well. Oh, yeah, you could probably just keep a latch gate, but it will probably cycle through. So, one method of doing this is to do this. Let's reset this to 000. We want it so that, where are my tools? Want this to be an OR gate. No, wait, my mistake. Should have set this up beforehand. Again, just one take. I want this to, I believe, to be a XOR gate, where we do not want it to be true for both. So we won't change the input. So currently right now, this is outputting false, that's outputting false. So, well, we are at count, quote unquote, 1, but count 2, count 3. Now, if you look here, 0, 1, 1. Hypothetically, if I should shoot this, the counter does not increase. So you can have it like that. So this is basically an example build on how you can make targets so that you can, so hey, in this challenge, make sure you double tap each target. However, thank goodness, or hopefully, that Anton, Nathan, and I think they mentioned Luke or Lucas, sorry about the third name, is working on an actual counter module and an actual mathematical comparator. So you could basically send two counters, one counter that's like the set number and another counter, well, that increases. Because as of right now, this is basically like a hard equal sign, where unless I put this stop, it would send it false if I ever do, greater than 3 shots or less than 3 shots. It has to be 3 shots. Oh, well, if you're smart, you could probably figure out the right circuitry to do a greater than 3, like 3 and greater, or, 3 or less, or, math operators. But as of right now, a quick equals sign of 3 equals 3. So yeah, this is my convoluted build. This is basically a 3-bit memory. This is 1-bit, 2-bit, 3-bit. And again, for every bit you add, you times 2 to the nth power of how many access numbers or counts you can have. So yeah, super cool using just an SR latch. I'm like learning. This is way more than I learned in electrical engineering 101 in college. But yeah, just a fun thing where you can set it so that you can make a special target system where how do I want to reset this? I need to make a better reset system. There we go. Where you can make a target, have to count first of confirmed hits. But yeah, hope this inspires people to get crazy with it. But again, all of this binary counting system, I really hope you're gonna get a integer counter soon. And luckily, unlike last time, the save feature works, but partially. So all these modules, they keep their states, right? Except the wires. In like one test, when I loaded up, the wires disappeared, so I had to rewire everything. But again, hopefully that gets all resolved soon. But yeah, see you guys later.